This chapter talks about forces within the earth, and specifically, we start off with what causes earthquakes. So, there's different s- stresses and strains that basically cause plates to break. So, the first term that I want to bring up is stress. That is the total force acting on crust rocks at the crust per unit area. So this when a stress is strong enough on a rock, meaning the force on it is strong enough, it's high enough, the rock will fracture. And to fracture is to break something. And that makes it move. And it causes this movement along the fault. And this movement is called an earthquake. And we feel that earthquake sometimes if it's strong enough, we will feel it. So, another type of force that is on rocks is called a strain. And a strain is in your book, it defines it as a shear or being having compression or tension on it, and the rocks can be twisted and squeezed and stretched. And here's some good pictures of that. So if you have a rock with no strain on it whatsoever, it might look something like this. But if it's being compressed, and by compressed I mean decreasing the volume of the material, like compressing it down to something smaller, then it might look like that. And tension is sort of when you're almost like rubber banding it and pulling it apart in different directions. That would be called tension. And the last type is called shear, where it's like in this picture, it's a great picture. It's like pulling one part of it to the right and one to the left until you like shear it off or like cut it in half by moving something in different directions. So there's two ways that rocks can get altered. There is elastic deformation, and then there's plastic deformation. So this isn't the best picture to show you here, but we'll stay here. So elastic deformation is caused when basically the rock is being compressed or bent or stretched, and basically, when that force goes away that's causing it to bend or compress or stretch, when that force goes away, the rock can be like an elastic, that means sort of like a rubber band, and kind of go back to its regular shape. So when it's all done being like pushed or pulled or whatever, it'll go back to its original shape. That's called elastic. The other type of stress that can happen is called a plastic deformation. And a plastic deformation, if you've ever heard of plastic surgery, that's a permanent change that somebody makes to their body, right? It's permanent, though. That's the important thing. It's permanent. So a plastic deformation is a permanent change or a permanent deformation. That's the way your book says it, where it's permanently changing the shape of the rock. Meaning, even when you let the force off, when you're not even pushing it anymore, it's now permanently in a new shape. It's just staying there because it's been totally changed by that force. So, basically, this can be the rock breaking or the rocks twisting permanently or compressed permanently or what have you. It's just a permanent change in the rock. So this is called a stress strain curve, and on it, you'll see at the beginning part you have elastic deformations. That means that the strain and the stress is high and the rock is being bent and twisted, but at any point here, if you let off until you get to something called the elastic limit, if you let off, the rock will return to its normal shape. But then once it gets to its limit, now you're talking about a plastic deformation, meaning the rock is permanently going to be changed in the way that it looks. And it gets to a point where there is a failure here, And a failure is basically the point that the rock ruptures or breaks permanently. And so that's called a failure. Maybe it crumbles, maybe it breaks off. So a fault is basically a fracture or break in the earth where the earth has moved or will move some more in the future. And a fault plane is specifically the surface where these movements are taking place. So the orientation of these fault um, planes, they can be straight up and down inside the earth, they can be horizontal along the earth's surface. And in fact, if you have seen like faults underneath the earth, we kind of tend to think of big faults. Like here in Southern California we have, well, not just in Southern California, it goes really far north too, but we have the San Andreas fault. And we think of faults as being really big, but there's actually tiny faults all through the earth. And these little faults are different cracks, and some of them can go straight up and down, and some of them are sideways. So some are horizontal, some are perpendicular or vertical to the ground. Okay, so I want to show you different types of faults, and I have to be honest, I like this chart because I like charts. It helps me organize information. But I like the type of fault and I like the pictures. I do not like the descriptions. I feel like they left out information, and I will go over that with you now. So different types of faults can be a reverse fault. And here you can see that this piece of land is pushing inwards, and so is that one. They're pushing towards each other. And so one is having to dive down and one is going up, okay? So this is called a reverse fault, where they're reversing kind of over one another. So here it says compression causes vertical movement upward along a fault. It also moves horizontally. So I want you to think of this moving horizontally and vertically towards each other is a reverse fault. So horizontal and vertical movement towards each other. Then a normal fault will move horizontally and vertically, but away from each other. They're kind of pulling away from each other, is a normal fault. And then we have the strike slip fault. And in strike slip fault, you have two plates that are moving horizontally but in opposite directions. So one's maybe going north, one's maybe going south. So they're moving in opposite directions, but there's still going to be a lot of like grinding past each other as they move. And this is, in fact, the San Andreas fault is a great example of that. And so the next thing that we're going to talk about is earthquake waves and how these waves, because this is really what causes the energy in an earthquake. So with earthquake waves, there's something that I'll give you their names first. A P wave stands for primary wave, and an S wave stands for a secondary wave, and then you have something called the surface waves. So this arrow down here is showing the wave direction, so that this is the energy. The wave direction is really the energy of the wave, and you can see that in this picture it's moving to the right. And the particle movement, where it says particle movement, I really want you to think it's almost like the rock or soil, like it's basically the earth, okay? The moving earth. So in this, in a P wave, which is usually the primary wave, so it's the first wave usually to reach a location. The primary wave, its particle movement will move in the same direction as the wave energy. So in this one, it like compresses, and it will kind of move back and forth as it compresses the energy, okay? And then the next one is called a secondary wave. And a secondary wave, this is different. It actually has the wave energy will move in one direction, but the particles, meaning the earth, the land, the rock, will move up and down. So this is actually a perpendicular movement, okay? Where the particles will move like this, but the energy is moving like that. They're perpendicular to one another, okay? So this is where like math terms become important in science. And then the next one is called an S wave. In an S wave, the wave direction is like this way, again to the right, but the particle movement will actually roll in a circle. And if you can imagine, having a rolling movement will actually cause a great deal of damage, okay? So the particles move sideways, side to side, and they move up and down, and this makes a rolling surface wave. So I actually have a little animation. Oh, I hope it comes up. Um, where I wanted to show you this. I wish I had this a little bit better. So there it is. Okay. So in this one, you can see this is a P wave. This is how this moves. So a very compression, straight, nice, organized little wave, right? Easy to predict straight along with the P wave. Okay, so this one is the S wave. And you can see that the land is moving up and down, and the energy is moving this way. So it's a very perpendicular. And then the last one is called the surface wave. And there are actually two different types. And I'll show you these two different types of surface waves, but just generally you need to know that surface waves cause cause a lot of damage with how they move. Because it's just a very circular motion. So how is that different from the S wave? So I'll show you the S wave one more time. There's the S wave. And then here is the surface wave. Okay, so let me move back to here. The next thing that I want to talk to you about is the focus of an earthquake is where the earthquake actually occurs. This is usually really far down into the earth. So this is really far into the earth. Usually, when it's closer to the surface, it's going to be usually an earthquake that you feel more. But usually an earthquake is somewhat deep inside of the earth. When they are shallower, you tend to feel them more. And that's called the focus of the earthquake. That's where there was actually a failure or the earth broke. Okay. And if you draw a line straight up from there, like this, draw a straight line up, then that is the epicenter of the earthquake. So the epicenter, the very center of the earthquake on land, is the epicenter. So we tend to think of the epicenter as where the earthquake happened, but actually it's where it was the closest point on land to the actual earthquake or failure that happened. And so it's right above is the epicenter. So I hope you have fun as you're moving through earthquakes and learning more about them. This should be a fun chapter.